All right, so this is the lesson for 5.4, having to do with properties of logarithmic functions, and this is part 1. We're going to cover the idea of logarithms for products, powers, and quotients. We're going to be able to expand them so that we have each of them as an individual logarithm, and then we're also going to be able to put them back together so that it is only one logarithm. So the other thing we're going to do is simplify our expressions using log base a to the x and a log base a x. We'll talk more about that towards the end. Alright, so our product rule, on the face of it, looks very confusing. It looks like we're saying, okay, well, log base a, where we have an m times an n, all of a sudden we're doing addition. But keep in mind that what we're dealing with is really the exponents. Okay, so if I have a 4, and I have that raised to the 5th power, and then I have a 4 raised to the 7th power, right? When we go ahead and do this, we take a look, and instead of it being this here is the multiplication, all right? But what we wind up with is we're going to have, again, there's our base. Now we're going to have 12 because we've added these two exponents together. Hopefully that's making some sense, and we'll go through each of those, each of our rules to see how they work, keeping in mind that our log is having to do with the exponents more so than the bases. All right. So here we're asked to basically smush this together into a single log, and so we have a log base 2, p to the 3rd, and then we have a log base 2, q. And in this case, we're going to go ahead and put this back together. We've got a log base 2 on both of these, right? You have to have the same base, so it becomes log base 2, p to the 3rd, and then that's going to multiply with q. So there's our original, and there's our log base 2, and then we have the parentheses around it to make it real clear that it's being multiplied, not that we forgot to put a plus in there. All right, our power rule. If you have any positive number m, any logarithmic base a, and any real number p, we can take our log base a, m raised to the p power, and it's the same as saying p log base a, m. And hopefully I can make it make some sense here. We're going to go ahead and go back to our 4s and address it. All right, so using our 4 to the 3rd power, we're going to raise this whole thing to the, let's call it the 7th power. I don't know why today I'm doing 7s, but there we go. All right, so in this case, we would have, remember, when we have a power raised to a power, it's the same as multiplying it. Okay, so what's happening here is I'm going to multiply my 7 and my 3. Well, when I do that, keeping in mind that I'm dealing with exponents, if I multiply that 7 times the 3, right, that's going to give me the same as this exponent coming down in front. All right, so this becomes our new exponent that we're dealing with, even though it doesn't look like it at first. All right, we're gonna do some practice with this, and hopefully as we go along, it will make some more sense. Alrighty. So we have a log base a, 11 to the negative 3. We're going to address that. We're going to have log base a, cube, no, 4th root of 7, and then I have natural log of x to the 6th. So let's go ahead and do each of those. So here's our original. We have log base a, 11 to the negative 3. So it becomes negative 3. We bring that exponent down, and then the log base A of 11. Okay, so here I have a log base A, fourth root of 7. Well, our fourth root is the same as an exponent, 1 over 4. All right, that's going to make the difference. So log base A, 7 to the 1/4. And then we take that 1/4 and we bring it down, right, or 1/4, and then log base A, 7. And here's our ln, x to the 6th. So that becomes a 6 ln x. All right, quotient rule, same kind of deal. All right, so if I have, and again, I'm going to stick with my 4s on this. If I have a 4 and a 4, let's go with 9 and a 3. Okay, so this is my 4 raised to the 9th power divided by my 4 to the 3rd. All right, and keeping in mind, we're talking about our exponents, right? The exponents, how they behave. We are going to say 4, 9 minus 3, right? Because this 3 4s is going to cancel with 3 of these, which leaves me just 4 to the 6th. All right, so this part is what's happening here, right? This part, the 9 minus 3, is the part that's happening here. Hopefully that is a little clearer. Sometimes it's really difficult when you have it just so abstract and you can't actually see how it works. Hopefully this is helping so that you can see how it works. All right, so we're going to express this as a difference of logarithms. We are going to have log base t, our 8 over w. So here's our original starting place, and we're going to pull that apart, so it's log base t8 minus log base tw. And I want to be really, really clear here. You have to have log base t in front of both of those. All right? You can't have it just be log base t8 minus w. That does not work. Those are not the same values. All right, so we're going to express this one as a single logarithm, and we're actually going to take it all the way as far as we can simplify it. So here's our original. We've got log base b, 64, minus log base b, 16. And then that becomes log base b, 64 over 16. And if you pause and think a moment, that's got some stuff we can cancel out. We've got some 4s that we can get rid of. All right, so it's going to wind up being log base b, 4. All right, this one's going to get really interesting, and I'm going to just pause on this one here. I'm going to stop and come back to this screen. But I want to point out we've got a multiplication set, we've got a division piece, and we've got powers going on there. So this is going to be a fairly involved process, which is why I want to stop here and we'll pick it up later.